See the red thing.
Yep.
I think it's pretty hot, so go back out to
I need a purple pill.
today.
Not today. Should have taken it before I started eating, right?
What is it? We got silver coming up, it looks like.
That's the hard
paper.
hard stuff.
What color?
That's the green one.
Silver gray. Silver gray. Anybody want some crust? I got some left over.
Where'd you get that rope from?
The what?
It's a secret. ask him where he got his rope for his pen.
The purple pouch. 14, fire
Is that a Crown Royal cord?
One flat.
Hey, silver team blue.
Didn't have a silver shoe. Oh, background. All right, this is the final presentation from the Silver team. My name is Jonathan Briere. My teammates are Jordan Bucher and John Colbert. If I'm allowed to, I'm going to reintroduce the whole background for our system, starting with a description of the physical system, the steady-state operating curve. I'll walk you through the state response, side response, Bode modeling, the root locus modeling, and P controller design. I'll then talk about what's featured in today's presentation, which is the P only and the PI experimental results. I'll then end with some conclusions.
After Kevin's presentation of that crazy voltage system in the range of what, 10 to 60 volts? 10 to 70. This is probably going to look like a piece of cake, right?
No.
Yeah.
You saying you want to skip it?
What?
You saying you want to skip it?
Good job, Jonathan.
One clap, Jonathan.
No, what I'm saying is, anytime you see something that's just as boring as the green, say, Jonathan, it's really boring and interesting, say, Jonathan, why didn't you just call it quits when you had all those? Whatever. Okay. All right. Okay.
So you want us to feedback?
Here's the block diagram for our system. The system is more
Skip.
input percentage.
Mark the resume, please.
I like to start with this beautiful diagram.
That's it. I'm not.
Okay. Step response, average gain. Notice this guy sticks way up. I thought that was interesting.
Nice.
Step response, step model, sine, those. Root locus? Yes, really good. Okay. So, we ran the model for the root locus. You can see our ultimate KC is 5.5. Our underdamped KC is 0.4. And the value below that value of 0.4 results in an underdamped response. Here's just a summary of our KC results for root locus model. Moving along to the P only controller design. As you can see in the upper left corner, this is for the KC, the critical KC value, which results in uncontrolled oscillations. Bottom right corner, this is underdamped, where there's no overshoot. Here's a summary. Here's an example. Okay, after we did all the modeling for our system, the system broke and the pump was changed.
Everybody say,
Oh.
Very unfortunate. And this made all our previous results garbage.
everybody say,
Oh.
And therefore, when doing the PI control experiments, we could not compare them back to the model. So the process we took in the control experiments is to run the system at a baseline of 70% and see the steady state output for that 70%. We used this output and used it as our set point for the P control experiments. This is an example of an experiment. We moved actually from 100% back to the set point at 70%. And you can see the input levels right around 70%, which agrees with the previous slide. We then did some PI experiments for the same KC values that we ran for the P controller experiments. Here's an example of a PI experiment. Ran several of those, and you can see the data for that initial baseline of 70% input. And you can notice some very large settling times. Anything about the system took a lot of time. And this concludes my presentation. The customer got what they wanted. What did they want?